Okay, hello everyone. Welcome everyone. So sorry about the delay. I have a technical issue. Maybe the line. I'm not quite sure though. But now I'm connected with the internet and also the MS team also. Okay so far. Oops. Hello. I've been muted. Hello. I've been talking alone actually.
Hello?
Hello.
Yes, we can hear you.
Oh my goodness, I've been talking alone all this while. Okay, all right. Okay, let me start again, yeah? Okay, welcome everyone. I'm so sorry about the technical issue. Thank you for joining us for today's webinar. This webinar is organized by Association of Professional Technicians and Technologists, known as APTT. My name is Kismet Anak, moderator for today's seminar. Therefore, I would like to introduce our presenter, technologist Hor Han Tin. He is currently working with Beckhoff Automation Center Berhad, serving as Senior Customer Service Engineer. He obtained his Bachelor of Engineering in Electrical Electronic from University Tunku Abdul Rahman, Uttar in 2011. He has been working with, he been working in various industries and companies with different position since 2012, such as project engineer, technical engineer, assistant technical manager, and customer service engineer. For those who just joining us, welcome to today's webinar entitled Back of automation in the advantages of a PC-based controller in 3 tiers BMS solution that will be presented by technologist Hor Han Tin. For just a little housekeeping before we get started, kindly be reminded that microphone should be muted at all times. Switch off your cameras, and recording is not allowed. Yeah. If you have any question during the presentation, please type your question in the chat box, and our team will compile all the question, and we will bring it up at the end later. Okay, at the end later. Now, without further ado, we would like to turn the time over to our presenter, that is Hor Han Tin. Okay, a bit this. Okay. Technologist Hor Han Tin.
Yes. Yeah, let me share my screen. Yeah, so thank you, Professor, for the introduction. Good afternoon to everyone, and thank you again for joining us today. So in today's topic is a Beckhoff automation on the advantages of PC-based control in 3-tier BMS solution. BMS is a building management system. So without further ado, let us look at the agenda for today's presentation. So I will start today's presentation with the introduction and PC-based advantages, followed by PC-based control in IoT, industrial Internet of Things, and lastly, I will have a sharing on the application of success story using the PC-based technology. So first of all, let me share in solution generally that Beckhoff is providing to our customer. So from left to right, you can see Beckhoff implement the open control system using the proven PC-based control technology. The main area that the product range cover are in the industrial PC on the first left, and then the next is I/O and field bus component, and drive technology, and lastly is automation software. The name is TwinCAT. So TwinCAT is stand for the window control automation technology. So it is the software that transform the IPC into a real-time control system with combination of the I/O modules and the motion. So TwinCAT is the one engineering software that we'll use to programming and commission the project. So all these product range can be used as a separate component, or it can be integrated into a complete and a mutually compatible control system that are available for all the sector. So to look into the advantage of using the PC-based controller, we can start by comparing the solution that offered by other player in the market, such as a PLC or DDC. So commonly, DDC is a standalone system or also similar to the PLC that is using a rack or chassis in the backbone communication, and the footprint, we can see that it will become big because there will be a unused a slot for a spare, or it will become less scalable because when the rack is full, it will need to replace or add a additional rack when you want to scale up the control system. If you look at the bottom, the PC-based control use the remote I/O concept. You can see the I/O terminal is a modular with a 12 mm width, and you can direct terminate the field termination cable into it directly, and you have a high scalable because due to the CPU of the PC with the high processing power can cater up to a 65,135 I/O in one control system. So the card is just easily expand and scale up. Just connect expand to the right side, just connect side by side on the remote I/O. Well, next we will look into the connectivity. So when an NCU in the control system want to communicate in a third-party communication protocol that itself doesn't come with, so oftenly you will introduce the gateway inside the control system. So when you add a third-party control system, it will make the control system become more complicated and difficult to diagnose the error, and it often require another software to configure. So the main purpose of the gateway is to translate a third-party protocol to support to the NC to translate to the protocol that is supported by the NCU. Or when you look into the PC-based
Excuse me.
controller,
Mr. Ho, I think you have a problem with your slides. We couldn't see it. Perhaps you can reshare your screen.
now you can see.
Not yet.
Okay, let me close it. Can you see now?
Not yet. Blank.
Mr. Harry?
Yeah, can you see now?
No, but perhaps you can probably turn off your camera and then share your screen. Maybe the connection is not that strong.
Yeah, can you see my screen again?
Yeah, we can see your screen.
Yeah,
Okay.
now getting better.
So just now is from which slide?
We stuck at I think slide number 2.
Yeah.
Sorry.
Okay.
Next, number 3, I think. Yes, we stuck at this slide.
Okay. Yeah. So from the picture, you can see that on the top is a PLC system. So it's using a backbone, and also is using a rack or chassis as a backbone communication. So you can see the footprint will be bigger because there will be used up the slot, and some slot is unused. So it will have spare and less scalable because when the rack is full and it will need to be replaced to a longer rack with a more slot, or add additional rack when you want to scale up the control system. While on the bottom is a remote I/O for the PC-based controller. So you can see the width is just a 12 width with a direct termination wire, and also with a high scalability due to the CPU processing power. It can have up to 65,535 I/O. Well, when it comes to the connectivity, you can see on the top, which we can think of is a NCU in the BMS control system. So when you want to connect to a device that the protocol is not supported by the NCU, then oftenly it will introduce a third-party gateway system to translate the protocol to the protocol that's supported by the NCU. So it will become additional, it will have additional hardware in the system topology, and the overall system will become more complicated. Okay. Well, come to the bottom, our communication terminal can just add on the right side. So it just depends on what protocol you want to add. So just add on the right side. And the library is already ready in the software. So just add in the library. Well, when come to the flexibility, our software development is free of charge, and you can try all the feature. While some other players in the market the software for different purpose, you will need to install another software. So let's say for the programming, you have one software, while for the SCADA or the server, you need to install another software. And some the development software, the business module, they will charge by a subscription fee, or the development license is they will charge a fee. So for us, the software development is free of charge. Okay. So currently for most of the control system, especially we are in the trend of the industry 4.0, the requirement of the control system is now is higher. Is often require the network to be connected, no more standalone system, and also require more data storage, because now commonly people require to analyze the data. They want to have a data logging. So it will require more data storage inside the controller. And also the control system need to be user-friendly and have a short development time, so it able to communicate with the other system in the network. So, and also it require a open standard. So traditionally, the DDC and NCO is designed just for the automate the system. So if you want to add in the additional feature, PC-based control will come into the picture. So the advantage of using the PC-based, you can see on the screen is, in brief, it integrate all the different system in one hardware and simplify the system. And you have a high scalability of performance due to the standard of the CPU. Okay. So when come to the building management system, BACnet, the building automation control network, is the most commonly used protocol. So our PC-based control also can support this protocol, and the BACnet also is widely used in the HVAC, lighting control, safety, and also a fire alarm system. So the twin-cat BACnet from Beckhoff is one of the most open and flexible solution currently available on the market with the certification for the revision 14, and Beckhoff has implemented the version of the BACnet standard that is currently used in the building automation. And extension of the BACnet standard, it can be easily to be added in the future. Okay. And also the BACnet allow user to access all the BACnet object and their properties from the PLC and also the visualization. So user can observe and change the state of the object. Okay. And come to the PC, the BACnet certified controller is widely scalable. So from the ARM Cortex processor, it can scale up to 2-core Atom, 4-core Atom, and also a Celeron i3, i7, depend on the application, how big is the application, and also it will require a higher performance for the bigger application. Then when we look into the I/O terminal, is a very slim with a 12 mm width and a 100 mm height. So it also come with we can direct terminate the wire with the catch clamp and with the IP20 protection. Then on the top, you can see the LED status indication. And we have a 1, 2, and 4, 8 channel. And we also have a 16 channel with the 12 mm with terminal card. So it will reduce the footprint of the control system. And for the signal, there's available in the digital input, digital output, and also the analog input and output. And with the RTD thermocoupler, we can direct terminate to the controller. Okay. While for the communication terminal, we can add the communication protocol that is required. So for example, if the control system require a BACnet MSTP, so we can just add, and also the Modbus RTU, loan work, DALI, CANX, and also Notion protocol. So we can have a multiple protocol in one control system. So after all the hardware, we can look into the software. So all the protocol that commonly used in the BMS here is already available in the library. So with the TwinCat software, you can just call the function inside the library and communicate with the protocol that require in the application system. Okay, so let's look into the typical 4-tier BMS architecture. So you can
Technologies Hor Han Tin. I think your slide freeze again.
Okay. So now is which
stuck
slide?
at the BACnet solution for Beckhoff scalable performance and wide range of function.
Okay. Now, can you see the 4-tier BMS topology?
Not yet. Still blank. Okay. I can see that slide now. PC-based control system in building management system. Typical 4-tier BMS architecture.
Yeah, correct.
Okay, all right.
So for
Okay.
the typical 4-tier BMS architecture, so you can see there's a 4-tier in the topology. The tier 4 is a field sensor. Then tier 3 is a direct digital controller, is a DDC. So it works for data collection and control, the HVAC and also the actuator. And then to link between the workstation and the DTC, it will require a network controller unit, NCU. So NCU is the purpose is for the communication gateway in between tier 1 and tier 3. Then for they also can use the third-party communication like Modbus RTU to connect to the digital power meter, and also some scheduling feature to the chiller. So you can see here is a 4-tier solution, which typically used in the BMS architecture. Okay. So now I change to the next slide. Here is showing 3-tier BMS architecture. So you can see that the NCU and DDC is already combined in a one PC-based control. So on the left side, this is a embedded PC, and on the right side is a.
We still stuck at the 4 tiers slide.
I think let me change my internet connection.
Okay, I noticed that the slide referring to 3 tiers BMS architecture.
Okay. So the tier 2 NCU and TDC is already combined in a one tier. So you can see in general, the system topology become simplified, and all the field wire is direct terminate, and all the function can be integrated directly. So let's say the scheduling feature, the PID control, mobile communication is directly integrated to the controller, and also it can direct link to the workstation SCADA with the BATnet communication or other commonly used protocol in the BMS. Okay. Okay, so next this is showing the system topology that using a different type. So you can see here is a line topology, and it support also a star topology and also with the ring topology. So the topology is very flexible, so it can install in a different level or different part the building architecture. So you can also support. Okay, next, here is a short video that is showing the Pirelli, a tire company that utilize our PC-based control and also the Dali lighting to increase the energy efficiency. So I will start playing the video. I think let me restart my PowerPoint.
Have you started the video?
Let me restart my PowerPoint.
Oh,
I
sure.
will start again.
The technology whole is the video
Yeah.
meant to be silent, or this without sound?
Use hands-on.
We can't really hear the sound.
And we share again.
occasional.
Now have sound.
Okay, getting better.
At their company headquarters in Breuberg in the Odenwald, a low mountain range in southern Germany, Pirelli Deutschland GmbH has now been developing and producing tires for more than 110 years. They currently have an output of approximately 6 million car and 2 million motorcycle tires a year, primarily for vehicles in the premium and luxury classes. All in all, Pirelli employs some 2,800 people in Germany, with more than 200 of them working in the research and development department. For Pirelli, ongoing quality improvement and high environmental compatibility are integral parts of the entire value-added chain. Sustainability also played a critical role in the modernization of the lighting system in a warehouse measuring 200 by 50 meters.
Wir haben uns hier den Ist-Zustand der Halle angeguckt und haben
We took a look at the current conditions in the building and realized that the lighting system here was very old, which meant that the illumination strength was much less intense than it should be. Many of the lamps were broken and the reflectors were also very dirty. The lights were on around the clock 24 hours a day, 7 days a week, even though the actual activities here in the raw materials warehouse do not always require this amount of illumination. And then it dawned on us that what we really need here is LED lighting. Thanks to this LED lighting, we already have been able to reduce the power input of the lighting from 20 kilowatts to 11.5 kilowatts. For us, energy efficiency is very important here at this location, and we started to think about how we can improve it even more. Then we decided to use a Beckhoff control system to track the movement of the forklift trucks. The forklift drives into the aisle and the lighting is switched on only in the areas in which the truck is moving around. And then the lighting in the neighboring areas is dimmed accordingly. That means that the lighting already knows when the forklift moves into the next aisle and that it then has to switch on there.
dass sie dieses auch einzuschalten hat. Jetzt leuchten diese Lampen nur noch, wenn
Now these lights are only on when there are workers in the area and only stay on for as long as they're working there. The system knows all the driving and walking routes. As a result, neighboring areas can already be slightly dimmed and only stay on for a preset time once the area has been vacated. Passageways are always set at the minimum level.
wir haben dadurch eine Einsparung
This translates as a savings from 20 kilowatts, which is what we're using up with the old lighting system, to a final 1.5 kilowatts. That's an enormous reduction, a bit more than 90% than we are now saving here.
uns eingespart haben.
This form of intelligent lighting control system can be used for any area that is constantly in operation, but where the lights only need to be on occasionally or at certain points.
Okay, so this is the video that showing the customer using automate the control system of the lighting from the traditional fluorescent and then change to the LED and then further optimize the lighting with the daily control and automate with the sensor, and the saving is up to from beginning to end, the saving is up to 90% on the utility bill. So next we'll move forward to the second section of the presentation. Okay. So I will, since we are using the PC base in the control system, so I will talk about how the software TwinCat help customer to achieve the IoT by utilizing the PC base technology with the predefined library and also easily to establish the communication. Okay. So in general, our controller can direct communicate to the clock using the commonly used clock protocol. So for example, MQTT, MQP, and also OPC UA. So the controller can direct connect to the internet and publish the data to the cloud. And then on the right-hand side, you can see a mobile device. So Beckhoff have a mobile apps that is free to download that you can visualize your control system data in a mobile phone that utilize a MQTT broker. So the TwinGate function provide the easy connectivity for LTE communication. So it support both of the public and also the private cloud system and using the standardized MQTT and OPC protocol. Okay. So let's look into a different scenario that we can help customer to connect their control system to the cloud. So you can see on the first scenario here that is using a TwinGate3 controller. So it will communicate directly to the cloud using the common protocol. Whereas when if the existing control system or third-party control system that enable to communicate to the cloud, our PC can act as a gateway that extract the information through the common protocol and share to the cloud. And then on the third scenario, we have a remote I/O here that no need programming. So we just connect the I/O on the right side. Then with the web browser connect on the web configuration, then you can publish the raw signal to the cloud. Okay. And also the TwinGate have a on-premise data analytic feature to perform analytic on-premise without publish all the data to the cloud. Okay. So here is the screen that showing the sample configuration. So we just fill configuration column and a parameter, then you can establish the cloud communication in few minutes. Okay. And then here I will also show a sample that how we can achieve remote monitoring with our IPC and also the software. Okay. So we will utilize the three feature in the software here. So the first one is a HMI server. The third is the MQTT library. And then lastly is the app to visualize the data on the mobile phone.
Tenris
So-
Hall,
Yeah,
are you still at this slide, cloud scenario supported by Beckhoff?
no, I already moved
I see.
forward.
Still stuck, I believe.
How about now? Is it jump to the my current page, which showing a video?
I'm still at this slide, cloud scenario supported by Beckhoff.
How about now? Is it on the video?
No.
Okay.
Can you unshare and then share again? Okay, I can see a twin cat
Next screen.
tree. Yeah.
Okay. Yeah, so let me straight jump to the recorded demo here. So this demo don't have sound. I would just explain when the video. Okay. So this is our TwinCat 3 software, which is a free the program and also the HMI. Then on the programming side, you can hear the programming is using the structured text and all the parameter is uh, uh, already key in here. So the programming language, it can support the ladder, logic, function block, sequential flowchart, different software. Then we can look into software design here. So this simple dashboard is just developing the board, like just drag and drop using the drag and drop from the toolbox.
Hello.
Yeah, can you?
Yeah. Okay. Technologies Hall.
Yeah.
We are stuck at twin cat free slide.
And why? Because the video cannot fast forward. So I just fast forward here. Yeah, so let's come back to the video. So just now we are stopped at the visualization HMI, and then here is a mobile phone app. So there's our customer and publish all the information through the APTT broker. So we can view the control system or the facility information live on the mobile apps. Okay. And it come with the, the live graph view. Okay. To the yeah. So I've done on the PC-based advantage and also the IIoT. So let's come to the third part. So here I will show some different topology that using a PC-based control. So the I/O terminal, we have various measuring terminal. So right now my screen should be at the solution architecture. And uh, uh, solution architecture that used in the BMS. So the current and the power can direct terminate to the measurement terminal, and light can control directly also because it also have a relay output card that can turn on and control the lighting as well. Okay, then here is a little bit different application that that utilize our XEX rated HMI that used on the offshore platform. So because of the customer using a old touchscreen and the touchscreen model already obsolete, and if you want to order a new one, the screen size will be a different size. So the customer need to re-engineer the whole user interface. So for this case, the customer look for us for a better solution because our HMI can automatically adapt to the different screen size because it's using the HTML5 technology that is same the HMI I demo just now. And also we support the third-party protocol like Profinet to communicate to the existing PLC. So we can also, the PC-based control also can be suit itself into a brownfield application. And then this is a sample solution architecture from our water industry customer. So for the remote area, the customer is using our panel PC, which combine the PC and also the touchscreen and come with the communicate with the USB GSM modem. So this can control the water with the inverter PID feature, and also provide a remote monitoring feature for the customer, because the customer can remotely monitor the performance of this system. Okay. And then next, this also from our water industry customer also, because they have a remote location, they have many remote location which unmanned. So they install our controller in the remote location which is very far away. Then they can standardize all the information back to the controller using the internet connectivity of the GSM modem. So all the information from the remote will be, and then will collect all the information and visualize in the user interface. Okay. Yeah. So this is the last application that I want to share. So this is used in the firefighting panel. So we can communicate with the firefighting panel with the panel communication, and then we collect all the information, and we can provide a remote, we can provide a remote notification. So for example, we can send a Telegram notification to notify the person in charge if they have any alarm in the system using the PC-based control. Okay. Yeah, so I think that's all from my side. Yeah, I've done the presentation.
Oh, okay. All right. Hang on a minute, yeah. Okay. Okay, thank you very much, technologist Hor Han Tin. We have some issue on the on the slides, video during the audio during the presentation. However, I believe that we also enjoy the presentation. Okay, let's move to question and answer session. Then we have two questions actually. Technologies Hall. Something related to the PLC from Muhammad Afif Z. He asking about, is it this PLC are explosion proof or not?
Yeah, so we have a different controller. So we also have the explosion proof panel PC that I showed just now in the process industry, the offshore. So we have a different type of the controller that you can choose.
Okay. Okay. We move to the second question from Muhammad Iskandar. The question related to normally how long is the reliability of this system and its validity working after the system run well and handing over to client. So as you know, the devices and part of communication is grow and updated very fast. So technologies, how?
Okay, so the reliability of the system, I can say, is very long because the so the communication, the MTBF, the mean time before failure of our the PC-based controller is very long. Is I think is can be more than 10 years. And also, we have also customer sending back the controller, which already more than 10 years, and we are still providing the spare part and also the software support to the customer, because all the Windows image and the software is using the Windows, and all the firmware and is customized from our Beckhoff.
Okay.
Yeah.
Yeah. All right. Another question from Nazri Muhammad. The questions sounds like this: are these BMS going to replace SPKA, SCADA system soon? Technology Hall? Hello, Technology Hall? Are you there? Technology Hall? Are you there?
I'm not sure what is the
SCADA? SPKA. I'm not quite sure. So what does this SPKA stand for? But I think it's related to SCADA.
Yeah, can you hear me?
Yes. Mr. Nazri, are you here?
Yeah, so the iSCADA,
Yeah, SCADA. Yeah.
yeah, can you hear me?
Yes. Now, yes.
Yeah. So the iSCADA actually offer the similar solution that I shared just now on the last slide, but our solution have more advantages because it is very flexible, and you can add on many feature like the notification, email, the data logging, and the SMS. And the most important is the programming software, the development, we can hand over to the customer, and customer can take over the system, or it can optimize the feature by the customer, because our software is not a proprietary.
Not provided with.
Yeah, it's not proprietary software.
Oh, okay. Okay, I just knew that SPK is stand for Sistem Pencegahan Kebakaran Otomatik. Okay, thank you very much, Said and also Nasri. Okay, any more question? Any more question from the floor? Okay, it seems like no more questions, and we have run out of time. It looks like we have covered all questions. Technologies Hor Han Tin. Is there anything that you would like to cover before we wrap up? Technologies Hor Han Tin.
Yes. So I just want to share the just want to share the 3-tier solution in the BMS as a more advantage than the typical 4-tier system. Yeah.
Okay. All right. So I would like to thank you very much, Technology Hall. I would like to invite our chairman for Association of Professional Technicians and Technologies, APTT, Engineer Technologies Ahmad Zawi Kasmin, to present the certificate to our presenter, Technologies Hor Han Tin. Is Mr. Chairman around? Oh, he also not around. Okay, we have some issue on maybe perhaps meeting, maybe attending meetings. Oh, okay. Mr. Ho, Technologies Ho Han Tin, thank you very much for your presence today and also giving a talk to our webinar. I hope that you can continue contribute to us when you are needed. So we will contact you after this webinar. Yeah. Thank you very much. Yeah. All right. We will send the electronic certificates to you soon. Yeah.
Okay.
All right. Thank you very much. Yeah. Okay. Before we wrap up, we'd like to invite everybody to switch on your cameras for photo session. Okay. Miss Bell.
Okay, if everyone can turn on their cameras, then we can take a quick photo.
Oh, very quick, huh? How quick? Okay.
Okay.
Siapa yang ada rambut bolehlah ni touch up sikit. Yang ada rambut tu paham lah.
Yang saya tak ada rambut. Saya tak ada rambut.
Doktor bagi comel lah Kismet.
Ya ke? Terima kasih.
Okay.
Okay.
Okay, hold on, yeah. Okay, ready? 1, 2, 3. Hold on, yeah. Okay, one
Ada
more.
CPR pula.
Okay, another one. 1, 2, 3. Oh, one more. 1, 2, 3.
I noticed someone is still
Okay.
wearing mask. I thought it's not compulsory anymore. How can we recognize you if you're wearing mask? Okay, everyone. Thank you again, Technologies Hall, for answering all questions and also the great presentation. It was a great pleasure to have you with us. So to conclude this webinar, on behalf of APTT committee members, we appreciate your presence. We hope that you have learned and also enjoy this webinar. Thank you again for joining us today, and we will see you next time. And please stay safe. Yeah. Okay, everyone.
Thank you.
Okay, thank
Bye.
you.
Okay, bye-bye.
Bye.
Thank you.
Oh, merah
Yeah,
juga
thank
baju
you.
Monica. Merah juga.
Merah.
Ya,
Au.
hati-hati oh, takut lembu attack oh.
How are you?
Good. So far so good.